What are we going to achieve by the end of this video? We have an application running in Kubernetes. That application is saying, hello Docker, and the magic starts happening when you change the code and push it to GitHub. As soon as you commit the changes, a Jenkins job gets submitted automatically, builds a new image, pushes the new image to Docker Hub, changes the deployment file with the latest image ID. The new image automatically gets deployed to the Kubernetes cluster using GitOps, and our application starts pointing to the new pod. Pretty exciting, but let's not get ahead of ourselves. Let's start from the beginning. The topics we are covering today are GitOps Workflow for the demo, along with the difference with traditional DevOps workflow, Dockerfile and Jenkinsfile walkthrough for the demo, Jenkins installation, Jenkins jobs setup, ArgoCD, which is working as GitOps installation, ArgoCD setup, automating GitHub to Jenkins using Webhook, and finally zero-touch end-to-end, which is the state of nirvana. This is a fairly long video with packed content, so I've given timestamps for all these topics for your viewing convenience. Alright, let's get started. Let's start with the GitOps flow. So you, the almighty developer, is working on a code app.py, and then you push this code to a repository in GitHub named Kubernetes code. As soon as you push the code, a Jenkins job gets triggered which builds the Docker container image. The name of these Jenkins jobs is build image. It saves the image in a container registry. In this case, we are using Docker Hub. And the name of the container image is test:10. This :10 is the tag for the container image. This part is important. Every time your code is changed, a new Docker container image will be created with the updated tag. Coming back to the GitHub, you also have another repo for Kubernetes manifest files. The name of this repo is Kubernetes manifest, and we have deployment.yaml file in this repository. This deployment.yaml file should reference this newly created container image. How does that happen? So after this Jenkins job created this Docker container image, it will trigger another Jenkins job update manifest, which will update the image in the deployment.yaml. So now this deployment file references test:10. Now comes the GitOps part. We are using ArgoCD as the GitOps tool, but this approach will work with Flux as well. So GitOps continuously monitors this Kubernetes manifest repo, and if the state in the Kubernetes cluster deviates from the manifest files in the repo, GitOps will grab those changes from the GitHub repository and deploy it to the Kubernetes cluster. There is no container running in the Kubernetes cluster, and the GitOps sees that, so it is going to deploy the deployment.yaml file into the Kubernetes cluster. So in the cluster, we have the container with the tag 10 running. So this is for the first time. What if the application code app.py gets changed and pushed again? So in this case, the job build image will build a new container image and save the container image with the new tag test:11. Then this Jenkins job will trigger the update manifest Jenkins job, which will go and update the image reference in the deployment.yaml file. So now the Kubernetes cluster is running the container image with the tag 10, but the deployment.yaml file is referencing to the image with tag 11. So ArgoCD will detect that, and then it will terminate the container with the older tag and then create the container with the newest tag. The Jenkins jobs that is building the Docker container image and updating the manifest file is the CI or continuous integration, and the GitOps that is deploying the deployment file into Kubernetes cluster is the CD or continuous deployment part. So this is how a GitOps flow look like, but how will this look like with traditional DevOps without GitOps? With traditional DevOps, it is more of a push model. So the job which is updating the manifest can run kubectl commands to deploy those containers into the Kubernetes cluster directly. But what is the disadvantage of this? Well, let's say if someone goes and deletes the deployment in the Kubernetes cluster, it is not going to remediate automatically. You need to somehow get alerted, and then you need to rerun this update manifest Jenkins job to push the changes back to the Kubernetes cluster. Whereas with GitOps, as soon as something changes in the cluster, GitOps will immediately detect that the cluster is out of sync with the GitHub repository, and it will immediately bring up the deployment. There are a couple other advantages of GitOps which we will go through in a minute. So in summary, GitOps periodically syncs the running cluster with the desired state in Git repository. GitOps works with both vanilla manifest files such as deployment.yaml or with Helm charts. It has reduced learning curve than DevOps because GitOps is utilizing Kubernetes concepts. Under the hood, GitOps is using Kubernetes operators. So you don't need to learn different DevOps tool to implement the continuous deployment portion. GitOps also increases the security because the CI and the CD permissions are separated. It also has less number of components. So this is the part I was referring to from traditional DevOps flow. So if you have implemented the CD part using Jenkins, you know you have to configure a lot of the stuff. Since GitOps is running within the Kubernetes cluster, there are less number of components to create and manage. And the last point is GitOps does not mean getting rid of DevOps. You still need to have the continuous integration part through the DevOps. Also, GitOps only comes into play when you have at least one cluster up and running. To spin up that one cluster, you have to use DevOps. Alright, enough theory, let's jump into the demo. Let's go over the GitHub repositories first. This is the Kubernetes code repository where we have our application code and Dockerfile. Our application code is app.py. It is a very simple Python program which is importing the library Flask and just returning hello Docker. The file requirements.txt lists the external library Flask, and in this case we are specifically using the version 1.1.1. The Docker file dockerizes that Python program and creates a container image. It is using the base Python 3.8 Docker image, and then it's copying over the requirement file, running a pip install of the Flask. Then it is running the Python program accepting incoming connections. Now let's go over the Jenkins file. So this Jenkins file is for the job which is creating the Docker container image. So the first stage, it clones this repository into the Jenkins environment, and then it builds the Docker container image. So basically it looks for a Docker file in the repository that it just cloned and then runs that Docker file. This Raj80 Docker ID is the account ID in my Docker Hub repository, and test is the repository name. If I go to my Docker Hub, you can see this repository is currently empty. This step does not push the container image yet. The next stage is just a dummy placeholder. So in this step, you can run some unit testing. In the next stage is where I push the image to Docker Hub. So you give the URL of the Docker Hub. The next part, Docker Hub, is not a standard keyword. Jenkins jobs will go to the saved credential and grab the credential saved under ID Docker Hub and use that user ID and password to push this container image. So if I switch to my Jenkins, you can see under credentials, I have this ID Docker Hub and I have my Docker Hub user ID and password saved under here. We will go over this when we set up our Jenkins environment. And we push this container image with the tag of build number of this job. So as you keep pushing more code changes, these Jenkins jobs will keep resubmitting itself with the new build number, and that will be used as the tag for the new container images. Note that this env.build_number is a standard variable, and that is available readily in any Jenkins job. You don't need to define this variable anywhere. And in the last stage, we trigger another Jenkins job to update the deployment file, and the name of this job is update manifest. And we are updating the deployment file with the build number from this job. So we have to pass this build number. And we are passing that build number into a parameter called Docker tag to this job. And the update manifest job will use this Docker tag parameter to update the deployment file. We are going to see that in a minute. This is the Kubernetes manifest repository. So this repository has the deployment file and Jenkins file for the Jenkins job to update the deployment. So if we go to the deployment.yaml, the container image is referencing to the latest tag. It doesn't matter because if I go to my Docker Hub, this repository is empty. first time we run our Jenkins job, it is going to update this tag. And in the next step, we are creating a load balancer service to talk to the container. By default, Flask application runs on the target port 5000 in the container. So that's why the URL of the load balancer will be using port 80 for you, but it is redirecting the traffic to the port 5000 of the container. I have opened the Jenkins file for updating the deployment file on the right with the deployment.yaml on the left. So the first step is very similar. It clones this repository in the Jenkins environment, and the second stage, it updates the file. So it sets the git config user email and username for the commit history. And then I'm running a cat deployment.yaml to show you how it is before we change. And then we run this sed command to change this container image. This sed command is using the symbol plus as the delimiter because we cannot use the default front slash because our container image has front slash. So sed won't work. So sed-i means it is going to do a in-place replace in the file itself instead of creating a new file. And then I'm looking for the line which has raj80 dockerid/test. Dot asterisk mean anything afterwards in the line is fine. And I'm replacing that with raj80 dockerid/test : $docker tag. Remember, Docker tag is the parameter that this Jenkins job will accept as an input from the other Jenkins job. And I'm doing this change on the deployment.yaml file. And then I'm displaying the deployment file again to show you. And then I'm running git add and git commit and git push. So now let's go over the first line. In the first line, note that this credential ID GitHub is fetching the credential saved under the ID GitHub from the Jenkins credentials. If I switch to my Jenkins, you will see the ID GitHub has my GitHub credentials. Remember that the password of the GitHub should be your token and not the password. So we'll go over it when we set up Jenkins. And after it fetches that username and password, it runs the git push command for this Kubernetes manifest repo and updates the deployment file. All right, so now let's jump into Jenkins and set up the jobs. For Jenkins installation, I'm following official Jenkins on AWS documentation. So I don't want to spend too much time going over each step because most of you already have a Jenkins up and running. Those of you who want to follow, like as always, any open source documentation with Kubernetes and Jenkins, you start running the commands. Some commands don't work. Then you bang your heads against the wall. Then you search Stack Overflow, and then you run those commands. So some stuff doesn't work from this documentation as well. So I'm just going to point them out. And also, if you're thinking, why am I not running Jenkins on my personal desktop? It's not going to work because to automate end-to-end, you need GitHub Webhook, which needs the actual URL, not localhost. And also, I'm using a t3.small EC2 instance, not t2.micro, because t2.micro, after the burst limit is done, it's like super slow and very frustrating. So you will incur some charge if you use t3.small. Also, another thing, connecting to your Linux instance, I'm not using PuTTY. I'm using the newly released connect option from AWS console. It's pretty straightforward, does not need any keys, and it's very handy. Okay, now after you SSH into your instance using the connect option, you start downloading and installing Jenkins. Everything will work up to here, but then this is the main command to install Jenkins, and this will fail. You will get this error, and then you have to run these commands to fix it. All right, going back, then things will work, and then you can unlock Jenkins, configure it, and all that stuff. But you also have to install a couple of extra things. You have to install Git in your EC2, and you have to install Docker on your EC2. Again, I have given everything on the description, so follow those steps. All right, after you run all those things, Jenkins should be up and running. So in my screen, Jenkins is up and running. Now this next part is important. Then you need to set the credentials for Docker Hub and GitHub. We are going to use Docker Hub for our Docker repository. To do that, click Manage Jenkins, manage credentials. Under global, click Jenkins, and then global credentials, add credentials. This ID field is important because we are going to refer to this field from our Jenkins file. So I'm going to name this Docker Hub. I'm going to add another credential for my GitHub. I'm going to name the ID GitHub in this case. Note that the username here should be the username of the GitHub, not the email ID that you use to log in with. So if you go to your GitHub repository, and you should see a name for your account. In this case, it's saha-rajdeep. So that's what I'm going to use, not the login email ID. And the password is not your GitHub password. You need to generate a token, and that's what you need to use in the Jenkins. To generate GitHub personal token, you go to GitHub, and under your profile, click Settings, scroll down, go to Developer Settings, and then Personal Access Token, and then you can put a note, and then select Repo, Webhook, Notification, and that should be sufficient. Click Generate Token, and this is the token you need to copy and paste it here. Now that Jenkins is up and running, let's create the build image job. To create a new Jenkins job, click New Item, give the name Build Image, and then select Pipeline, click OK, scroll down to Pipeline, and instead of giving the pipeline script here, we want to grab it from GitHub, so select Pipeline script from SCM, and then Git under SCM. Go back to GitHub Kubernetes code repository, click Code, copy the HTTPS URL, and then paste it in the repository URL. My repository URL is public. I kept it public so that you guys can go and fork it. But if your repository is private, you need to give your GitHub credentials here. Now under branch specifier, change this to main. So you have to adjust this accordingly. All the new GitHub repositories, the main branch is named as main. But if you are forking some old repository, it might be named as master. And for now, we are going to manually submit this Jenkins job, so I am not setting up the GitHub trigger yet. So click Save. Now let's set up the update manifest Jenkins job. Go back to dashboard, new item, give the name update manifest. Note that this name should match whatever you use in the Jenkins file for the build container image job. Going back to Jenkins, this is also a pipeline job. Click OK. Then select this project is parameterized, and then add a string parameter. And name of the parameter is Docker tag. The default value is latest, but we are going to override it from the previous job. And then scroll down. Same thing here. We are going to grab the Jenkins file from the Git. And in this case, you have to give the URL for the Kubernetes manifest repo. So go back to the Kubernetes manifest repo, copy the HTTPS URL, go back to Jenkins, and then paste it here. Same thing here, update the branch to main, click Save. All right, so now let's try to run this. Go to the build image job and click Build Now. While we wait for that job to complete, this is an excellent moment for you to click that like button and subscribe to this channel. Every like helps this video reach new viewers and help this channel grow. Also, if you are looking to learn Kubernetes, system design, serverless, CloudFormation, CDK, DevOps, Git, and GitHub, check out my highest rated and best-selling courses. I will give the link in the description. All my courses come with a 30-day money-back guarantee. If you don't like the content, you get your money back, no questions asked. This is an excellent way to support me and help this channel grow. All right, back to our job. All right, now it's triggering the manifest update job. So let's go to manifest update job. All right, you can see this job is automatically submitted. Now I want to show the output from this. So click this and then console output. So note this deployment.yaml before we changed it. So the container image here shows the tag latest, and then our ACD command ran, and then the container image changed to tag1. Now let's go back to Docker Hub. Remember, it was empty. Let's refresh the page. Here we go. Our very first container image is in the repository. Now we are going to go and set up the ArgoCD. Now let's go over the ArgoCD setup part. So I spun up a EKS cluster, which is a Kubernetes cluster on AWS using eksctl create cluster command. But note that this demo will work with any Kubernetes cluster. It doesn't need to be on AWS. For setting up ArgoCD, I'm going to just follow their documentation. I'll give all the links in the description. So I'm just going to follow each step. So I'm going to install ArgoCD. Next, I'm going to download ArgoCD CLI. So if you are using a Mac, you can run this brew install ArgoCD. I am on Windows, so I'm going to run choco install ArgoCD CLI. Note that if you are using the UI like we are, you don't need to do this, but I'm just going to show you just in case. And you can access the ArgoCD API server using a load balancer or ingress or port forwarding. For this demo, I'm just going to do port forwarding because that's the easiest. So note that once you run this command, this terminal, the command will keep on running. So I'm going to create another terminal to run the other commands. But at this point, our ArgoCD should be up and running. So let's go to localhost :8080. You will get this warning. You can ignore it because we are just running from localhost. All right, in the username, you give admin, and to get the password, you copy this command, go back to terminal. So I'm going to switch to the other terminal. And if you are running in Windows, you can delete this base64. So I'm going to run this. So you'll get this output. So again, if you are in the Mac and you can run the full command, you can just copy paste. But in Windows, we have to decode this base64. So go to this base64 decode encode and then decode. So this is the password. Go back to ArgoCD, sign in. Now we are going to set up the ArgoCD part. And before we do anything, we are running kubectl get pods in our Kubernetes cluster. And as you can see, no pods are running. Now let's go back to the ArgoCD console. And to point this GitOps ArgoCD to our Kubernetes manifest repository and deploy this app, click New App. You can give any application name, but I'm going to give the same name as I used in deployment, which is Flask Demo. Project default, sync policy automatic. What it does is ArgoCD will check every 3 minutes with the GitHub repository and check the state of the cluster, and if it is out of sync, it will apply it automatically. If you select manual, you need to manually sync it. For all these other options, you can hover over the question mark and they're pretty self-explanatory. We're going to keep everything as is, and in the repository URL, you have to point this to our Kubernetes manifest repo. So we are in Kubernetes manifest repo, get the HTTPS URL, go back to ArgoCD, paste it here. And if you kept your manifest files in a folder inside that repo, you have to give that name of the folder as path. But since in our case, everything is under the root directory in the GitHub repository, we are just going to give // as the current folder. And then the destination determines which Kubernetes cluster it is going to deploy to. So this is a cool thing about GitOps. You can run GitOps in one cluster and you can deploy this to any other Kubernetes cluster. If this GitOps is running in the same cluster as you are deploying this application to, then you just select this kubernetes.default.svc. And we want to deploy this application in the default namespace. Keep everything as is and then click this create button. It actually deployed the application. If you click this, it is going to show you the flow. It created this load balancer, and then behind the load balancer, there are 3 pods. So if we go back to our terminal and now run kubectl get pods, we should see 3 pods running. To get the load balancer URL, run kubectl get svc, and it should give us the load balancer URL. Note that it will take a couple minutes for AWS to provision load balancer. So I'm going to copy this, go back to my Chrome, open a new tab, paste the URL, press enter. There you go. It is accessing the Flask application and it's showing hello Docker. So now only thing left is to automatically trigger the Jenkins job whenever I push my Python code to the repository. Alright, so let's set up this push webhook from our code repository. To set up the webhook, you need to go to the Jenkins dashboard and copy the URL. Then go to your Kubernetes code repository, click Settings, and then select Webhook. Click Add Webhook, and then give the URL of the Jenkins, and then you have to add GitHub-webhook / at the end. This part is important. If you don't give the / or this GitHub webhook, it is not going to work. Under content type, select application/JSON, and then select just the push event. Click Add Webhook. And now you have to go back to the Jenkins job and tell that trigger that job anytime it receives a webhook. So go to our build image Jenkins job, click Configure, and then select GitHub hook trigger for Git SCM polling. Click Save. Alright, everything is set up. Now it should be zero touch. So let's go to our application code and change something. I changed the hello Docker to please subscribe, like, and comment on this video. Thank you. Let's go down and click Commit Changes. Now this should automatically trigger the build image using the webhook. Here you go. This job got triggered. It built the image. Now it's pushing the image. Now it's triggering the update manifest. So let's go to the updates manifest job. All right, this job also got triggered. All right, this job is complete. So if we go back to our Docker Hub, refresh this. Now we have a new Docker image with the tag 3. Number 2 is skipped because I tested with number 2 before recording this video. And if we go to the deployment file, this should have the new tag as well. Here you go, test:3. Now let's go back to our ArgoCD. This should update as well. And by the way, you can have different views. You can have this Kubernetes object view or the network flow view. I prefer this view. Alright, our ArgoCD detected something changed. It's terminating the old pods and creating the new pods. So if I hover my mouse, you can see it created the new pods with the tag 3 and it's terminating the old pods with tag 1. If we go to our kubectl terminal, if we run kubectl get pods, you can see the older pods are terminating and new pods are coming up. Let's refresh the application page. Let's refresh this page. Alright, as expected, the Kubernetes load balancer service is pointing to the updated Docker image with the updated code. Alright folks, we did it. End-to-end deployment into Kubernetes cluster using Jenkins, DevOps, and GitOps. Alright folks, if you like this video, if you found this video helpful, please click the like button, subscribe, comment, ask me any questions about this tutorial. That's it for this one. I'll see you guys and girls in the next video. Bye.